All right, so first things first, for the circuit board, we're obviously going to need the neopixels. So I guess we got to figure out exactly which ones we want to get. Let's just go find Adafruit's website. The bright ones. Yes, that is a good idea. We should definitely get bright ones. Are there any other kind? The reason, so I'm looking specifically, there's a few different ones that are free floating. SK6812, I've not ever worked with those. I've only worked with the WS2812 types or 2811. So probably just going to go with these. It matters too because it will be, depending on which ones we get, will change how difficult they are to place on the board. WS2811 inside, but fixed 800. Okay, 800 kilohertz, that's fine. Those ones are out of stock. What are these? I've not seen these ones before. Huh, interesting. So these ones exist to go on the other side of the circuit board, and like basically you put a cutout in the circuit board and it sticks through so that the top of it is very smooth. Interesting. I don't know what protocol it uses though. Transmission time. So we'd have to go through and compare this and decide if it's okay. Yeah, interesting. I'm not going to use these. I just wanted to check them out real quick. All right, we'll probably go with the standard ones then. This is what I kind of had in mind anyway. 1655. All right, let's go see. DigiKey has no sock. They do. 2,979 in stock. To ship immediately. All right, we're going to do that one. It's the 1655. All right, let's see what we get here. Hopefully somebody's already made a model for it. It's a fairly common part, so I think so. Yep, looks like they have. Perfect. Well, I'm only planning on putting 5 on the board, so 10. A 10 pack gives me a few extras in case I mess up. I just wanted to see if somebody made a footprint, because it's usually the part they skip out on. But yeah, all right, looks good. 2D looks fine. Cool. All right, let's place these then. Where would these be best? Probably just right across the top here. 2, 3, 4, 5. All right. I gotta get used to using circuit maker again. There we go. Let's turn off that. Thanks, book. Oh, I'm getting a phone call. Potential spam. That's unfortunate. I'll have to decline that for now. I think it was last stream, a tick that told me that I should start answering those on stream, and I decided that was a horrible idea. All right. 5 volts. So each one of these has to be powered by 5 volts. And then the data lines, each data line going out goes in directly into the next one. And a nice little daisy chain. And that one can be unconnected. That's true. That is very true. All right, and then I need the ground. Okay. Whoops. So FreeCAD and this use different like maneuvering things. So like right clicking in FreeCAD is like rotate or something, and then right clicking this is drag, and then clicking in the center in FreeCAD is move, and this one is zoom and everything. So like switching back and forth, I get all the controls mixed up for how to navigate around. All right. So there's usually a recommendation for these. I gotta find it. Oh, interesting. I think they want a capacitor on each power. I mean, that makes sense. You just gotta fit it in there. It's kind of annoying, but... And then I've seen before, too, where people put capacitors on these data lines as well, because without it, there's, like, it's glitchy. So we should probably find something. Oh, excuse me. Just reading this article, trying to find an example of it. Additionally, too, so in the lightsaber project, one of the things we were dealing with all the neopixels was the power issue. We were having to use really high-powered components that could handle a lot of current. Because there's only 5 of these, that means the max it could possibly draw is 300 milliamps, which would be enough from a USB port to provide. So it's totally okay to just use a USB to power these. All right, best practices for neopixels. Oh, interesting. We probably do want to put a big capacitor right at the front of it. $300 to $500 resistor. Okay. I was looking specifically to see if they recommended a specific value or something. In this data sheet, standalone sign, or do you need to plan on powering it from an outlet? I plan on powering it from a USB port. I figured that was the easiest, most like straightforward thing, because then you could plug it into a computer or just like a charger, for, like a wall adapter. Doesn't look like they recommend a specific capacitor value or anything, so yeah, okay. I could probably put a big capacitor just right here at the front, and I think that will be okay. I probably don't need one of the data lines. I do need a resistor here, based on everything I've seen. Just to protect the data line going in, prevent a short or anything, so. All right. So let's do a 500 ohm 0805 resistor. One mega ohm. So apparently this 500 ohm thing that I put in was just a suggestion. Ugh. I was hoping I could just search something. This is always the most annoying part of using Circuit Maker, is trying to find parts that already have models made. So we'll go back to our friend DigiKey. And this is where the fun part is, trying to find all of the little parts that you need. Stock active. I want cut tape. I want 0805. And then 500 ohms. Only 4 remain. I wonder if 510 is too much. 510 is a much more common value, obviously, so it'd be a lot easier to get. 470, is that a common? Yeah, I think that's a common one. Let's go with that then. And now we have 1,001 parts here. So let's see if we can find one. Hey, perfect. Let's place that. Drop right there. It needs to be as close to the data input as possible. Okay. Oh, I forgot about the level shifter too. We're going to need that, definitely. All right, we'll turn this off. I don't need that. All right, and then probably a 1,000 microfarad capacitor if I can get that in this size. We shall see, though. Not really. I get a couple, though. Get 2 470s. Only one remains. 8. That's probably a better option. Oh, wow, those are expensive. All right, hold on. Let's try and find something a little cheaper. A lot more of those. Even more, or not that many of those. Quite a few 100s. That's honestly probably enough. If I put one on each pixel, I think that will be okay. All right, what sizes do these come in? There is some 0805s. It's probably pretty thick. And a bit pricey. Let's take out that. All right, let's sort by price. We need something that we can buy in individually, so cut tape. These ones. What package is this? 1206 metric. So pretty big, but I think that's fine. It really depends on, yeah, they haven't made a model of it. So we're going to play this game again. The cheapest thing I can buy that I can still get. Oh, okay, cool. This one has a model. It's how much? 75 cents each. That's pretty expensive for a part like this. Let's see, best way to do this. Yeah. 1, 2, 3, 4, 5. There we go. And we'll just keep moving all these around. And then we'll have to place each one of these as close to their respective neopixel as we can. There we go. All right, now we need ground for each of those. Okay. So that's looking good. I'm still debating putting a capacitor on each of these data lines. I might circle back to that because there's no way we'll finish this whole thing tonight, so I can get a chance to ask somebody about that, I guess. All right. We need a TNC. We need a controller. This will do. What's the 3D view look like? I want to find one with the, okay, yeah. That'll work just fine then, I think. Yeah, because it has the spacing for how it would be mounted. All right, one of these. Down here. We also don't have to worry about a connector for the USB because this thing has one built in. So we'll just use the one on this board. It does matter which pin we pick to power this thing off of, though. In addition, we need to make sure the 5-volt line it's got the on-off. That's interesting. Okay. All right, so we need to figure out where everything is coming from here. These are the most useful charts. I think if we plug it in through the USB port, this VN will be putting out the 5 volts that's required. But I need to double check that, so I need to see the circuit. Should be on here somewhere. Here it is. VN. There's also a VUSB. What is that? Or where is that? VN powers the entire board. Okay, so we just use VN according to this. All right, that works. I'll keep this chart pulled up. So, our 5-volt port that we've been using for everything else, it's going to be connected to VN. And this already has a capacitor on it, on the board, so it will be okay there. $27. This reads like there's a different pin that the USB would power. I guess there's not, though. Just looking at it. Oh, no, it's an internal pin. Okay, got it. So this isn't along the outside edge. It's somewhere else. It'd probably be better to use that one. So let's go ahead and do that. Okay, excellent. All right, now we just need the level shifter. And then I think that pretty much our entire circuit's done, actually. Usually the part used is usually the BSS 138, I think. And a ton of different people make this particular part. All right, here we go. So this is how it gets wired up. Low voltage, high voltage, okay. So now I just got to find one that I like. And I think we'll need just one of them, so that should be straightforward. Oh, there's already a model made for it. Perfect. All right, we'll need one of those. And then we're gonna need some 10K resistors for it. Let me move this over here. I'm gonna do this just like that diagram because it's just easier to understand that way. Oh, other way. 270 degrees. Here we go. All right, and then we need, let's get some wires going. All right, then we need a 10K resistor. Excuse me. Scrolling, scrolling, scrolling. There's a lot of options. Nope, that one. 10K ohms, 606 remaining. Let's go at A5. There's still 132. Wow, a lot of people make 10K resistors. There should be a lot of 10-cent options available. Let's go with the Panasonic one. We've been using their parts a lot. Picking their parts a lot. If y'all have any questions or anything, let me know. Okay, that is... Oh, that's a picture of the entire reel. I was like, there's no way that's right. Man, that footprint does not give a lot of room, does it? To solder to. Interesting. I'm still going to attempt it. All right, 90 degrees, turn that off. That goes there. And then up. That goes over there. Oh, we need to connect 3 volts. So VCC will be our 3 volt. And we need 5 volts over here. There we go. Probably delete that. All right, and then let's label these. Nope. Oh. For some reason it's throwing these windows up way over here on the other side of my other monitor. All right. This is 5 volt data. And 3 volt data. All right. And like I said, I'm still not totally sure about the capacitors yet. It may not be a bad idea just to throw like a microfarad capacitor on everything. Yeah, I think I'm going to do that eventually. Because worst case scenario, if they cause an issue or we don't need them, I can always just not place them. And they're pretty cheap. All right. Oh, we got to figure out where to connect the last few things. Let's move this whole thing over. Volt data. All right, and then as far as where we connect here, this actually does matter. Because there's a library that we use with our existing. We've already built some of the software we needed to for the what's it called? The Millennium Falcon. So I should be able to make use of that. But that means I need to connect it to the correct pin. Looks like it's pin 2. Okay, so pin 2 is the one we're going to use. Slide this over a bit. Which is this one right here. Okay. Perfect. I think that's everything. I think that's the whole circuit done. So let's add new PCB. All right, so we need to change our outline to be something that would actually fit. So we have our device here. The acrylic off the base. I actually probably turn the acrylic back on. So we need it to land right in here. With the teensy underneath and everything, so best way to do that. Really need like a DXF of this top piece right here. Can I do that? Can I export a DXF of a face? Let's just try and export and see what happens, if that's an option. It is a DXF. I don't know if it's exporting the thing. I think it is, though. Yes. I think I've had this happen before and it didn't do anything. Okay, well, we might have to work on that part later then, or try and do that later just to figure out how to do it, but I could probably use the sketches. Probably would have been the first pad. No. Second one. That's it. 2 or 4 inches by 1 inch. 4 by 1. And then we'll have to get the measurements for the bottom of the acrylic piece too. So let me take a screenshot of that. We probably want to go a little bit bigger too, to leave room for putting like a big metal pad for these standoffs to hit. That's what I'm thinking. Yep, we should definitely do that. And then we need to go look at the drawing of the standoffs to figure out exactly how big they're going to be. Let's close that. What is that? 92510A440. Let's go to McMaster. Let's see. 92544 92510A 440. Product detail. There we go. This right here. All right. And then I'll need the drawing of the screws, the mounting points there as well. So it's going to be one of these pockets after this pad. What's this one? I think that's it. So this is probably what we should go off most. Let me turn off a lot of other stuff. That, just so I can see it. Okay. So we have this. We have our PCB document. We need to reshape this. All objects, dimension. Interesting. All right, Google this real quick. Circuit maker change. If I just redraw it, will it just start over? Oh, that's just checking dimensions. Darn it. And I thought it was going to be easy. I guess we're looking for something called outline. Board shape. Redefine board shape. That's probably what we want. All right. I think we said we probably want at least 5 to 10 mils of space between the edge of any copper and the edge of the board. We're going to need copper for the screw holes, so let's do 50 mils just to be like extra safe. So it should be 4 inches, so 4,000 mils plus 50 on each side, so 4,100. Okay. And then it's 1 inch tall, so it should be 1,100. So not that much. All right, then we just go all the way back over. There we go. All right, that's our board outline. Everything's got to fit on that. I don't think it'll be too bad. Okay. So now we need to go back here. Update PCB document with everything. Validate changes. Make sure we got no issues. Okay. Execute. And there it is. Nice. So obviously we're going to be cutting it a little tight, but it shouldn't have any major problems. All right, this one. Bottom layer. There we go. And then if we look at the 3D model, hopefully it's upside down. It is. Interesting. Cool. All right, and then we need to, well, real quick, what size of the, there's the connector. So this needs to rotate. 90? Yeah, that's the right one. And then we will find a way to drop that right in the middle there. I guess if we're already doing everything in inches, we might as well just keep doing everything in inches. The whole mils thing. I don't know how far back this thing needs to go, but I do know that its y coordinate should be 550. Yep, that's right. I'm actually a little worried now. I don't know if I have enough space for the screws. I don't think I plan on how big this device is going to be. Or wait. Oh, I think the cutout's way inside, though. Yeah, it should be fine. So let's do the screws first. That would be the easiest thing to start with. That'll help me line up other things. Okay. So, need to add a pad or a via. Oh, keeps throwing the box way out here. All right. Round, multi-layer, yes. Designator, ground. I'm going to call it M1 for mount, but its net should be ground. There we go. Okay, size-wise. This is where we pull up the big master drawing. Should be a 1/4 inch wide on the outside. And the hole needs to be 140 mils. Whoops. That's 250 and 250. Okay, yep, that's more like it. Now the other one had them right on the edge. If we look at our drawing here, so from the centers, should be 375 mils away from the center, which we know to be at 550. So that's pretty straightforward math. But I'm still going to use a calculator to do it. Minus 375, 175. All right, that looks good. Gives us exactly 50 mils of clearance from the edge of the board. And then I need to do the same thing over here. So probably the same, exact same measurement, right? 175 and then 175, yeah. All right, let's get another one. Name it M2. 175. And what would this be? 550 plus 375? Right, so 925. All right, that's correct. This one needs to be the ground net as well. Cool. All right, let's get a couple more. Let's see, this one will be M3. Same net as well, ground. We know this to be 975, and then this one is going to be quite a big difference. 175 plus 1875 plus 1875. $39.25. So it's close. This is wrong. 925. All right, cool. So all of these are, oh, let me fix this one. M4 and ground. All right, I'm gonna go ahead and start locking these in because I don't want them to move. So all of these are exactly where they need to be to mount the board. Okay. Now what? We're gonna have the teensy on this side. I feel like we just go ahead and put the level shifter out here and then have it come up through the board and then work its way back. So come from this side over. I think that makes the most sense. So we need to go through and figure out. All right, so now we have board size. That's good to go. We have the mounting points. So next we need where the teensy can go. I think my software is glitched. Let me know if you can still hear me. If anyone doesn't mind. All right, so it's going to have to be, is it this one? Yeah, that's the pocket. .5 inches long, 0.8 inches wide, 0.2 inches over from center. So the center of the teensy needs to go, obviously, in the center. Audio's good? Okay, good to know. Thank you. So the center, we know that to be 550. And the center of this is going to be 200 plus 750, so 950 over from the center. Right, okay. And the entire board is 4,100 long, so divide by 2. That's where the center's at. So 4,100 divided by 2 is 2,050. And then from that, subtract 200 and then subtract 750. So 1,100 mils is where the center of the teensy needs to go. So 100, and then this needs to be 550. Okay, that's its ideal placement. So lock that in. All right, the next critical component, or the last critical component, are the neopixels. Everything else should not really matter that much. Just see what this looks like so far, though. Sure, we're getting the things we expect. I like how it leaves the spacing there for the headers to go to. Cool, looking good. The board seems really thin. I wonder if there's a thickness option. Let me check that real quick. Layer stack manager. Oh, maybe that's it. Oh no, that's just the... Oh, it is kind of giving it. Signal layers, 1.4 mils. We're gonna do 62 mils thick, so I probably need to up that. So what this controls is the thickness of each of the layers on the board, how they're drawn and everything. So we're gonna do 62 mils minus 4 minus 14 minus 14 minus 4 equals 26. No, I read that wrong. 62 mils minus 0.4 minus 1.4 minus 0.4 minus 1.4. 58.4 is how thick this needs to be. Okay. Is that legal? I assume so. So if I go to 3D view, does this... Oh yeah, see how much thicker that is now? That's what the board thickness is actually going to be, so... Okay. So that looks correct. Awesome. Alright, so now neopixels. So we got to figure out the width of a given neopixel and the length of the bottom of this thing, because I want 5 of them evenly spaced. Maybe I should have done 7. I guess I can always add more later if I need it. All right, let's close that on the acrylic. Pad and pocket, I guess, was the holes, so the pad would tell us. So this sketch, 3 inches wide. And it'll be right in the center. I guess it doesn't matter what the thickness is. It matters, though, to know how far away to place components. 1/4 inch thick. 3 inches wide, 1/4 inch thick. Okay. There we go. Just trying to make that, see that throws an error. All right, so we need to figure out how to place these. So how thick are they? Because that's going to change where I place the first one. I guess I could start with number 3 and place that right in the middle. Like just dead center. That'll give me a good starting point. Yeah, they are pretty bright. That's why I'm going with 5. I could, like, the beauty of these is I always can just like turn 2 off if it's like too bright, right? But what I'm worried about is this giant, like the lights are at the bottom of this giant acrylic piece, right? So it's fine in the shaft right here, but then when you get into this big circle, it, you know, the light is going to disperse. So it wouldn't be as bright. So that's what I'm working around. I want to make sure it's bright enough that when it gets to that dispersion, that there's still enough light in there. And because they are what they are, we can always turn them down if we need to. Or turn them off. 550. The center of this will be 2050. All right, let's... We won't lock it in place yet. We may change the rotation of it. D4 and D5. And we know the height of each one is going to be 550. So we just go ahead and do that. Okay. So now I need the data sheet. How wide is this thing? Oops. Five millimeters wide. So I need to go, okay, so I need to calculate. So from the center, if we look at our drawing here, hold on. This one tells us that that's 1.5 inches, and then we need to come back from that half of the thickness of a neopixel and drop it right there. That way the entire neopixel is under the acrylic. It's not halfway out. So they're 5 millimeters wide, so that's 2.5 millimeters. So they convert that to mils. Is it 98.4 mils? Yeah, just call it 98. So 1500 minus 98. And it's in the center, or from the center, so that's 2050 plus 1500 minus 98 equals 3452. So this one goes at 3452. And then this one goes directly between those. So 3452 plus 2050 divided by 2, 2751. And there we go. Interesting. I'm gonna go ahead and lock these in place so they don't move, and I'll just, so I don't want to accidentally like click and drag them or something. Okay. So now for the other side, for D5, we got to do, let's see, 2050 minus 1500 plus 98. So 648. And then 648 plus 2050 divided by 2, 1349 for D4. Oops. Okay. It's hard to tell, but I think that's centered because of the way the teensy is. Let's look at the 3D view again. Maybe that'll look a little better. Those look right. I think it's right. Yeah, I think it's right. All right, we'll roll with that. Maybe somebody could check my math later. All right, so where's... Oh, I might have done this a bad way. Where's DN? Oh, maybe not. What's the first one? Where is it connected from? Okay, yeah, this is actually, these are actually already oriented the optimal way. Cool. So now we just need to get in here and put the, let's see. I wonder if I can draw like a keep out or something. Or at least attempt to. So I want to put the bottom of the acrylic piece in here. That way I can, or that way I can see where it's going to be, so I can keep parts out from underneath it, and only the neopixels will be underneath it. But it keeps out everything. It's not specific. I'll probably be okay. How tall are the neopixels? 5 millimeters tall. That's almost a 1/4 inch. Where's power? That side? Okay. I'll just do my best to keep stuff away from it. I keep getting this warning. Interesting. Alright, so I guess we start with the capacitors. Oh, they are sizable too. It's probably a good thing I considered that. How much are they taller than the neopixels? They gotta be, right? Oh, they're not. In that case, it'd be fine. I might have underestimated how tall these things are, though. We might have to change our model for that. 1.6 millimeters tall. Well, that doesn't look like 1.6. Oh, maybe it is. Let me figure out how tall that capacitor is. Thickness 2.5 millimeters. So it is taller than the neopixels, which are 1.6 millimeters. And they'll be a little higher than we have to actually allow quite a bit, because when you solder them, they can rise up a little bit, depending on if you get solder underneath and stuff like that. So all that to say, we probably should keep them outside of a certain distance, just to make sure the acrylic doesn't bump up against it, if at all possible. So maybe run a power trace like up, over, around. I think this is our power trace. It is, okay. This is going to be a little tricky, actually, to fit them in here. Like, here's fine. We can put it over here, right? D4 is the only tricky one. We might just have to squeeze it in somewhere. Interesting. Okay. And then how far from the center do they need to be? How big is one of these grids? Is it 25? Yep. 50. Okay. So what's an 1/8 inch to mils? In mils, it's 125, right? So 5 squares from the center. 1, 2, 3, 4, 5. Okay, that gives us a little more room, actually. I was a little worried, but no, I'm not. So let me go find the one for it, C4, drag it over here. It's definitely close, but not catastrophic, right? How much space did I allow between the top of the circuit board and those 1/8" spacers? Mils to milliliters. Let's see. Where are they? Here. Close this. So this distance is what's important. It's quite a... Well, you got to account for the thickness of the circuit board. I forgot about that. Ooh. All right, we'll just put it in. We can always cut off the acrylic however we need to, make it a little bit shorter. If anything, that'll help us with the price of it, so... And then I think what that means is I'm just going to have to place underneath, because this spacing is so tight that I'm really worried about it. I suppose I can move the teensy over slightly, but I don't have a whole lot of room to move it. Yeah. All right, so best way to do this. I'm thinking this gets dragged pretty close by, like right here. I'm worried about those shorting together. See, that's one thing. Like they could definitely do this with the technology they have at the people who make the circuit board. It would just be really annoying to solder. Oops. All right, I think we take this, we rotate. So let's go 90. Nope. Let's go to 70. Wait. That's just the pad. And we'll just drop it right over here. Close, but far enough. All right, and then the next one, let's get the rest. I'm sure next time when we draw the traces, it'll be really fun to try and make all this fit. Thank you all for sticking with me tonight, though. It's been a little while since we made a circuit board, so this is actually kind of fun. Okay. And one more. Forgot about this one. All right, there we go. I think we'll actually turn this one. We'll put it back to 0. Then we can just slide this in here a bit. All right. So all of these can probably get placed at some usual interval. 675 is the height. That looks good, so let's just do that for all of them. Oh, that one does need to be different, so we'll just leave it. Okay. So that's at 1349. 1080. 1349 minus 1080 is 269. It's memory store. All right, so each one will be 269 mils away from on the x-axis of its respective neopixel. So this should be 1781. And then this one should be, what is that at? 2751 minus 269 equals 2482. And then this one 3452 69 equals 3183. All right. So I'll go ahead and lock all these into place. And I think this one already is. Yep. Okay. Now, all that's good. Let's get our one resistor into the right spot. It needs to be close to that, so. Oh, and turned around, it looks like. Now I'm thinking about it, maybe, well, no, because we got to do the whole level shifter thing here. Where's that line to data right there? We'll probably want to run it down around the outside here to keep it away from interference on the rest of these things. All right. Honestly, let's put these on the top as well. Okay, which side is 5-volt data? Okay, so this needs to rotate 90. Nope. 270. So a 3-volt coming in this side, 5-volt going out that side. This one goes on this side, this one goes on this side. And then we will rotate this. I guess this would go 90. Yeah, there we go. Drop it in nice and close right there. And then this same thing here. 90, and make sure it's close to this. And of course, VCC is all the way on the other side of this board. Is there one on this side? Because that would be really convenient. Hold on. All right, let's save all this. Let's go check the schematic. Is there a 3v3 on this side? There's this one. I think that's at the bottom of that board. Yep. Are those even populated in this drawing? Doesn't look like it. At least not all of them, so we'll leave that. All right, that's unfortunate, but it'll be the way it is. Huh. All right, I think that is good. And that basically means that's done too. All right, all our components are placed. So before we route it, I guess we should export it and then bring it into our CAD model. and see if it fits. And I know I've done this before. Design rule check, netlist board info, assembly drawings. I've definitely done this before, so there's got to be a way to do it. It exists in Altium, which is like the professional version of this tool. Let's go ahead and save it to the server. Just get everything up to date. Okay. Generate outputs. Export step. That's the one I want. It's cool that you can generate bill of materials and all that too. I don't know where it's going to put this though. Any second now. Hopefully this isn't crashing my stream. Quality still looks good, so I think we're okay, but sure is taking it a while though. Okay. Yes. Okay. There it goes. It just took it forever to do that. All right, good to know the stream is still good. Thanks for checking up on that. Really appreciate it. I don't think that's what I meant when I said view it. Well, there's the there's the step file. Apparently that's what the text of a step file looks like. Interesting. Very interesting. All right, so we're not quite there yet. Oh, come on. I wonder if this was an up. There has been a lot of updates. I wonder if this is an update thing. It's got to exist somewhere, though. That's the part that I'm not getting. Yeah. Oh, I think it's giving me a... Okay, interesting. I might have a location for where those files were exported to. Oh, I did. Okay, hold on. All right. Now if I go here... Come on. Ha! There it is. Oh man, it didn't include the holes. So I guess we have to hope that those are right. Axis, we needed to rotate around the X. All right, the center of it is right on the edge here, it looks like, for some reason. That's just where I decided to put it. I think. Maybe a little more over than that. Weird. Picked a really odd place to put it. I have no idea where the origin point of this thing is supposed to be yet. So I guess we'll just have to do this manually. I know this thing's 4 inches, so yeah, that's -2. Oh, it's got to be on one of the corners. It has to be. So what does that make it? It has to be this corner. Is that in the center then? Yep. I don't understand really what the height of it, like why it's where it's at, but I do know that, okay, that's why that's in the center. So it needs to go over 2050 mils. Negative 2.05 on the X. There we go. Is there a way I can like show the origin? I can view the origin of different objects. But I guess we just settle it down until it's as close as we can get it. Oh, I guess the Z axis might not be too hard either. Because it looks like it's lined up with the edge of this. So 1.75, so 0.875 on the Z. That gets it to the center. Then plus 0.375 more. So 0.875 plus 0.375, 1.25. Oh, that gets us to where that hole is. And then it's another 1/8 inch plus 50 mils. 1.25 plus 0.125 plus 0.05. So 1.425. Math. All right, and then we just need to settle this down onto this thing. Too far. 0.3. Should probably allow a little bit of room just in case. So 0.335 is probably best, because that leaves the tiniest bit of space. All right, as we can see, we have a bit of a collision between our neopixels and this acrylic, but I don't actually think that they are this tall. We can check that real quick, though. It's 0.1 inches. Right? Yeah, 0.101 inches. .54 millimeters. So yeah, that is significant. I think that's how tall the capacitors are. Yeah, they're 2.5 tall. So they're actually as tall as these neopixels, and the neopixels are probably about as tall as the capacitors. So it should adjust the acrylic anyway to be that height. That would be the ideal way to do it. Shorten the base of the sign that you extend the luster. Yeah, that's what I'm thinking. Just because even though the neopixels aren't that high, the capacitors are, and some of them are, they're kind of underneath it. So, lost all perspective here. There we go. Let's turn this acrylic back on. And acrylic has a certain variance anyway. Yeah, they're slightly underneath, it looks like. All right, so on the acrylic, let's go to that sketch. And then this 4.75. Should we allow a 1/4 inch is probably too much. Maybe maybe 4.625, give it an extra eighth. Should leave just enough room. Maybe a 16th. 0.125 divided by 2 plus 4.625, 4.6875. There we go. That puts it pretty close. And then, like I said before, if we need to raise or lower, we have these standoffs that we can mess with. All right. So that looks good. Let's turn that back off. And make sure... Oh, it's backwards. the teensy's it's on the wrong side. Okay. How do we fix that? We got to rotate it around the y-axis, 180 degrees. Oh, that's going to mess everything up, though. Crap. FreeCAD rotate part 2 axis. All right, somebody will hopefully explain this. Interesting. Okay. Placement. Apply incremental. Apply. Okay, and then we got to slide it back over on the Z. Okay. There we go. I need to get this thing back to like zeros, everything, and then reposition it. Okay. All right, so now I will go and do this manually. Next time we'll work on the traces and everything. All right, so we need to rotate around the X. 90? No, that's the 270. Apply. And then we need to rotate around the Y. 180. Okay. And then that gave its rotation for how to do it. And then I need to figure out how to get all this thing back into where it needs to be. Looks like it's mostly centered. Z is going to be 0.325. I think that's right. All right. And then settle it down. Negative, I think it's 3.35 or 0.335. And save it, just so we don't lose it. Excellent. It looks like the teensy drops right into that little pocket we made for it. Cool. No interferences there. And then we have a straight shot right up to the USB connector right in there. All right, I think that will work. And then hopefully we didn't mess up the acrylic. Okay, yeah, it's still where it needs to be. With a little bit of space. All right, perfect. So next time we'll continue with the circuit board. Let me just go ahead and make sure everything's saved. Looks good. All right. So we'll draw those traces and then that'll be done. And then I think at that point we basically got all of the parts designed, so that we just have to figure out a cheap way to make it. I have to locate somebody with a 3D printer. Yeah, that might be a tricky one. We'll see, though. All right, well, thank you all for joining me tonight. This has been fun. We made a lot of good progress, and we're getting really close to the end, actually. Laying out a circuit board as far as like the traces goes, that typically takes a little while because there's just a lot of little things you have to do, and you'll change your mind 1,000 times. So that might take a little while, but hopefully we can get it working, and because it's not too complex, hopefully it doesn't take too long. All right. Well, it's been fun. I will see you all on Tuesday. Later.